We just derived what the current is and the voltage. These are both the natural response of the RC. Now what I did is I went ahead and I plotted out this using a computer, just using Excel, to plot out what these two expressions look like. And let me show you that. So let's do a real quick example here with real values just to see how this equation works. We'll say that this is 1,000 ohms. That's our resistor. And we'll say C is 1 microfarad. And what we want to work out is R times C equals 10 to the third times 10 to the minus sixth. And that equals 10 to the minus 3 seconds, or 1 millisecond. That's the product of R and C. I forgot V naught. Let's say we put 2 volts on this capacitor to start with, like that. And now we can say V of t equals V naught, 2 volts, times e to the minus t over 1 millisecond. And that's our natural response for this particular circuit. Now let me show you what that looks like. This is V of t on this side, equals 2 e to the minus t over 1 millisecond. And you can see it starts at 2 volts and then sags down as we predicted. And that's an exponential curve. And then over here on this side, I, as we said before, starts out at 0 in the capacitor. The current in the capacitor is 0. And as soon as we throw open that switch, the charge charges over through the resistor. And this is the equation here. I of t equals 2 volts over 1,000 e to the minus t over RC, or t over 1 millisecond. So this is what we call the natural response of an RC circuit. And you'll run into this in almost every circuit you ever build.